So my first question will be, how did you end up at CLES-FACIL?
Okay, so after being admitted at INSA, I actually felt a bit lonely. I was just looking. I ended up finding CLES-FACIL, during the AG.
Okay.
Yes.
Because you were feeling lonely in the school in INSA?
Yeah, it was my first time in France and I didn't know anyone, so I wanted to meet like people. And on that day, they were showing they were advertising the clubs, and I was attracted by this yellow rocket. That one, because they were using it to display. So I just saw it.
Okay, so this one was at the Forum des Assos?
Yeah.
Okay,
Yeah.
so that's why you see the big yellow stick and you said, oh, it's for me.
Exactly.
Okay. And before that, did you add any patience, yes, about about space?
Oh yeah. I always had a passion for space.
Enthusiast?
Sorry?
A space enthusiast?
Yeah.
Yes.
I was a space enthusiast. I was really fascinated by how to build rockets and get into aerospace, and slowly one day,
And you still want to, I think.
Yeah. Yes. I still want to work as
You,
an
how many years have you been in INSA now?
Right now, 2 years. Yeah, the next academic year will be my last one.
On bachelor's.
Yeah.
Okay.
Bachelor.
And you don't plan to make a master's?
No, of course I'll continue maybe somewhere else. You don't know.
Okay. Yes, you can.
Yeah.
So, on what project did you work at first in the CLES association?
It was just ATREIDES. The time I joined advertising ATREIDES. So, that time, because when I went to the Forum des Assos, they were advertising it as the main project. So I came here and I was put into electronics with ATREIDES. Yeah.
You had prior experience with electronic at the time?
No, not really. I didn't know how to make a PCB.
So you were baptized with fire.
Exactly.
Okay. And on what part of the rocket did you work in this electronic part? You did not make all the electronic, I think.
No, I didn't make all the electronics. I worked only on the timer. Yeah. At that time, I worked on the timer.
How did your timer work?
Basically, it was program. It had a micro.
An Arduino?
Micro. Chip used 8.
Okay.
PAU, I think, and it was powered by a volt battery to step down to the logic for the microcontroller, and then the signal to a certain pin which would activate, send them.
Yes, it was a solenoid, so you had to put the high voltage 12 volt. Okay.
Since day one.
Okay. How many timers did you do?
I actually did the first one. We sent it to be made, and then Julie told me it was do it again, and it was sent to be confirmed by one of the members, and this time it actually worked. So I would say 2, but while soldering it, but that some things were not like the correct components, so it had to be redesigned. So maybe.
Only 3?
Yeah, only 3.
Okay.
Yeah.
And it was your first electronic?
It was my first PCB to like.
And PCB with a soldering in place chip on the chip you didn't have?
I didn't do the soldering, because that time I was not here. I was that time I was doing my internship, and then the following time when I was supposed to solder it, it was not possible.
Okay.
Yeah, so
on any of the 3?
Yeah,
you did the design and you did the rest?
Yeah, usually had to do
the soldering part?
Yeah.
Okay, that's why it never worked. Okay, I understand. And you made the timer part, and you needed to interface it with the experiment, or just the timer part was segregated from the rest?
Yeah, it was separate from the rest, because at that time usually I was told that it had to be.
Yes, but no. It has to be basically segregated in electrical component, but you have components that can communicate while being segregated. It's isolator, and you can have two circuits that work fine and communicate, and don't have then their electrical component. You can fry one The other one is fine. But
Oh.
you between them, I use them a lot, and it's pain in the ass, but they work.
Yeah, so for that time we
But
just,
it's more simple, especially if it's your first year.
yeah.
You at least you made something that, from what I saw on this space, was not frying or not working at the time. So, but I think you, for your first time designing, pretty good job, because I'm also work on hardware. It's 4 years now that I made a PC, and the first one was, I think you did a better job.
Actually, the one which went to this last C space was not my first one. Supposed to go to the first C
So you were at the space 2 years ago.
Did we go to the C space in 2020? No. Like the first one, so we didn't go. We didn't.
No, not the first one. You Astrid came 2 times at the space.
Yeah,
The first one it came
yeah,
last year.
yeah.
You were there?
No, RCEs.
Ah, yes. Okay. So maybe you see me then. No.
Maybe.
You had to redo all your timers once again.
Yes.
What did you make it different? Will you make it better if you have to make it something better or something else?
Yes, I will actually incorporate a backup system, and I will change the main system to be something totally different from the one which we made. So the main one will be relying on an eye to like deploy the parachutes, and then as a timer, this one can take over. And
Why do you want to have the most painful or not precise sensor in the entire space?
I mean, just like to know when the acceleration is like at minimum, to base apogee.
You sure about that?
Not quite sure, but it's something we would like to try.
If you want some raw data of an IMU, I can send it one. You will show that when the motor stops,
Yeah.
you see nothing. At the time the motor stops, you see nothing.
Oh. Okay.
You see 0G from this time to the end of your flight.
It was a concept in development. We were just trying to see. It was
The
not
most precise sensor in a rocket is a pressure sensor,
the
because you're going very fast, so you see everything that is going outside. If you want to see the speed and the altitude, you have something. It's a small. I give you a small conseil, advice, because an IMU, many people think that works. If you're not buying some IMU from Safran that has a precision, very big precision, you will see nothing after the motors stop.
okay.
But it's out of the scope. In the years that you have passed at CLES-FACIL, did you take any other responsibilities in other project or in the bureau?
Yeah. Member of the last year as a vice treasurer, and then
You have vice treasurer.
and then now this year I decided now to be now the treasurer.
Okay.
And in the past we tried starting another project, probe balloon done by ATREIDES, and we couldn't start that project. Yeah.
Okay. And this year you will work on Astrid 2,
Yeah.
if it's the name you choose, and not other project.
Yeah, I think we'll the ATREIDES and try to make it successful compared to the previous flight.
Yes. You put all your eggs in one basket, but it needs to be a very shiny basket. It's
Yes, yes.
okay. Before going to INSA,
Yeah.
where did you study come from?
Oh, I came from Kenya.
Kenya?
Yeah, so I studied in Kenya basically. After I graduated high school, wanted somewhere where I could learn, get to actually practice it in, somewhere with like good facilities. So yeah, I began searching. I found schools in Canada and France, but I got more interested in the French one. One, because of course it was cheap, and secondly, I wanted to one day hopefully work in the region around Toulouse, maybe in Airbus.
Toulouse.
Yeah.
Okay. Airbus for the space part.
Yeah.
Okay.
Yes.
But satellites or launchers?
It's not something I've thought about so much.
You need to thought about it better, because there is a clear. You work on satellites, Airbus, like rockets.
Yeah.
But a satellite and a rocket it's not something. There is very little overlap.
I am saying because in terms of I might decide to continue PCBs like stuff.
You will be happy with.
So maybe I might decide to now go to the launchers.
Want to make PCBs, which is a very good thing to do because not everyone likes it.
Yeah.
If you would like to have 7 layers and everything you want, you can go.
Into that.
Okay.
Yeah. Internship.
So thank you for your time and for answering all my questions. And, I think we are done. My first question is: on what did you work for your association? What did you do? What make you? Moi aussi, je vais recommencer. Why did you start working for the CLES Associate?
Well,
How do you end up here?
I was always interested in rocketry. So when I joined INSA, as first we had our forum des assos, so that too many associations, and I found CLES interesting because I was looking for an organization where I could learn about rockets, aircrafts, and use what I learned in the class. And for me, it was CLES and Mechasports here at INSA. So I liked more what CLES was doing. So that's how I found myself at.
And you from aeronautical to space. You don't space rather than aeronautical, or for racing team rather than space.
No, I prefer space over aeronautical because I believe a lot of development almost nearly done. It's pretty close, but I find the concept of the flying wing aviation pretty is working on one. But as far as space is concerned, a lot of new things to do.
Sûrement aeronautical.
No, I'm more space.
And when you came up to the CLES-FACIL association, because we are not talking about the spaceport now, on what project did you work? Did you end up at the start?
Yeah, so when I joined CLES, it was around the time they were getting CLES back on. We had a few years of silence before that.
Getting CLES great again. It's like,
not great, I would say working again.
Working again, because it's sort of period of non-activities.
Kind of, yeah.
Yes.
It was kind of gone dead. So when I came, they had already finished designing the rocket. Could do there. The only two departments that I could do work was in elec or so that's when I joined the XP team. Team for the rocket along with some of my yeah, that's how I started working. So when I arrived at CLES, ATREIDES.
Okay, you arrived at how many years?
Well, this is my second year at CLES, so ago.
So you saw it was 3 years that the project started. Is that right? The project started 3 years ago.
Yeah.
Okay. Higher and you started working on the experiments. And what did you work precisely?
I worked with Bogdan on basically the design and testing of the experience piece.
So when you say the experience, you mean the inertial wheel, flying wheel. Please.
Flying wheel. I worked on that, and a lot of work I did at CLES was administrative, part of getting one of our deals done with
sponsoring.
Basically, yeah.
Money.
We need money to do stuff, no?
Yes, you're right. You needed people to do stuff. So it was just you and Bogdan on the flying wheel experiment at first?
Initially, yes. Initially it was me, Bogdan, and then we had Zacarias join the team, 2-3, and we have been like the perm. Then people just kept coming and going and coming.
Can you explain to me with your own words how did your experiment is supposed to work?
I will try my best.
In the big box type, not every wire, but if you want, we can try to do every wire.
Yeah, I'm not the best person to explain the every wire part. Bogdan will do that. He will be very much obliged to do that. Propose the experience wheel, the inertial wheel, the flywheel method. So our basic idea was to create a system that helped from turning and rotating while it was like during its initial stage.
Why the flywheel solution?
When we were discussing, a lot of solutions were proposed. So the controlling the fin method was proposed, but apparently that was against French laws because then it would become a missile. So the other option that was feasible at that point of time, given the amount of manpower we had, or what we thought was feasible, was the flywheel. Got the amount of people that were going to work on the project, the amount of money we could spend on the project, and the amount of time we had. So together, in the end, we had to agree that flywheel perhaps was one of the more feasible things
Simple things to do.
we could do.
On the dimensioning part, how do you choose the size of your flywheel?
Well, choosing the size of the flywheel, we wanted something that was easy to install inside the rocket, big enough to counteract the inertia of the whole rocket. So what mass we needed, what volume of the cylinder we would need, and that's how we placed the order. So based on what rocket, what...
All of the mechanical part of the rocket was already... Okay, so it's not you that make this rocket a tank.
No.
Okay.
No.
Because it's a fucking tank.
No, that was not...
Right now.
I don't think it was the same as the one we used on the space, but the flying tank was very much...
That's what you call ATREIDES?
It's like 3 millimeters. It's not aluminium, it's
Yeah.
steel.
No, it's aluminum.
Aluminium, okay.
But it's 130 millimeters.
The people here have no role in designing the rocket. That's
when
it.
we came, the mech designed, and we just had to fill it.
Components.
So you had to work with what have already been done.
Yeah,
Okay.
basically, yeah.
On the choosing of your motors and your electrical system.
That we did, yes.
You did.
Yes, but I must accept that we made some oopsies while selecting.
What?
Well, many times. The most important one being we needed something that gave high torque, buy something that gave us high torque. And we did not realize that early on. So by the time it was, too late. So we had to make do with what we had.
The current limit.
Yeah, so...
The battery was limited for 60 amps, but we were running.
Yeah, so there was this instance where we were like, alright, so we messed up. What do we do now?
Okay.
So
It's during testing that you
realized.
How did you test it on the...
So we went to RCE in Paris. There they asked us, what is your proof of concept? And we were like, rien. So they're like, well, make a proof of concept. So we came home and we made this. Yeah. To simulate somewhat of BN during the launch. And then we put it on some ropes, hung it there. We have some videos of us testing it as well. Yeah, so that's when we realized that, it's not strong enough to turn the whole thing because we might have to supply more. And then from that, took it inside. We did it. We created a metal key to fix the motor to the experience cylinder. Yes. But what we did was we designed the covers of the XP with ABS. And so now PETG. With PETG. So now we have this connected onto it full power. So we gave it full power and so more like 200, 250 amps in. It starts rotating. So the cylinder rotates and now the cylinder is not rotating anymore. And we're like, what happened? The motor is still working. So we take it apart and we see that the key was cuboidal in shape. The hole was cuboidal in shape. After this test, they were like, well, we need to do something else. So then we had to machine the...
What was your estimated torque? You did
I don't remember now.
PETG is some strong material for 3D printing, so you had to do big torque.
That PETG melted. The torque was high enough to melt it.
It need to be...
Yeah.
It was...
Because at some point during the test, the key broke loose inside and it got so hot that it made it a...
Okay. So what did you do to correct for this many mistakes?
So after that, Bogdan lucky enough to find us a CNC. So we got a CNC that is inside, but the problem was the computer in the CNC was kaput.
Yes.
So Clem and Bogdan took one night. I think they took an Arduino Uno and quickly made a makeshift computer to make the CNC work. Okay. So we used that to cut an aluminium piece that would fit in between the 3D printed PETG and bind it to the key without burning. So yeah, we did this whole thing in one night.
It should be, if it's a key, It would not have been faster to do it manually, CNC, but like do one axis.
No, because we need like a specific shape for
Yes.
the connector to fit. And
Okay.
I don't think the lathe machine was working at that point of time, so we couldn't do it on the lathe as well.
Mm.
Also, we needed like a square hole.
Yes.
Yeah.
And so when you have your key, you had started testing your solution.
Yeah.
And when was the first time it worked? Like
Did it work?
You see the thing turning and you were like.
Okay. So once we did all of that, we got it fixed. I think this was around December or Jan. I'm not wrong, because around December in February. So that's when we did one final test before we left, and that's when we saw the whole thing work.
Okay.
Yeah. So we did the same thing after we got the whole thing ready. We put it back in, put it up, and at that point of time, what we did was we wanted to make a quick test. So this whole contraption was connected with a wire on top there, there actually, and we gave it a spin. So while it was spinning, we turned on the motor and
You see it stopping.
yeah. So it
And you didn't film that.
it is filmed.
Are you
Sure.
losing your mind at this time because of you're working?
Yeah. Well, hopes high at CLES. So we were still because we were losing our mind. We were all losing our mind. We were hopeful as well because at that point of time we were preparing. We had exams. We were working on CLES, and some of us are in some different associations, so we had work there,
Yes.
and we were working part time. So yeah, but after that test with the result,
And then you left.
and then we left.
So can you explain, because I didn't do some exchange, but what is your exchange? Why did you had to to stop working on your project?
For our program at INSA, we have 6 months of study abroad in Europe, all students. So in our class, we get to make two choices. Either we go to University of Strathclyde in Scotland, or we get to go to University of Twente in Netherlands.
You just have two shows.
Our program is not a very big program. We have like 30 students in our class.
Okay, yes, it's small.
It's a small class. So half of us went to University of Strathclyde, to University of to go there, and then we have to study plan.
Yes. When you were in exchange, did you support some activities that were going out in the class, like helping from abroad in Teams or Discord?
Yeah, so CLES at the time had 3 teams: the mini, the Fusée, the main rocket team, and the aeronautic team. So the aeronautic team was something we started last year. It was something fairly new, and at that point of time, even now, it's an all-girls team, and they are working on a glider.
Yes. Okay.
So we were in touch with everyone on Discord, and we were doing as much work we could do remotely. So the programming work, telling people what to do and how to do, Discord calls, Discord meetings, weekly, bi-weekly, monthly.
And during the space campaign,
Mhm.
were you also on support?
Yeah, we were on support all the time. We were watching the whole thing live on the website of
So
Planet
you
Sims.
saw your rocket launch from abroad.
Yeah,
During the fateful morning of. You saw your rocket launch
yeah.
and then take the big wind on the face.
Yeah, we could not see much because the clouds were low that day.
Yes.
So we saw it go up into the clouds, and then we don't know what happened because on the online launch they were like, well, they cut the live stream. We got a call from our members at C-Space. We can't find ATREIDES. We will try to find ATREIDES. And then we're like, okay.
During the launch, the rocket hit some heavy wind.
It was not very visible, no.
Okay.
We just saw it go up into the clouds.
On the site, we can clearly see it go up and like the rocket into the cloud, and just after the cloud, bang, a big bang, and we are like, okay, something has happened. I don't know if your teammate had recall you how this thing has passed for them, because they were just next to the launch rail.
Yeah.
I think they didn't tell you that much because they were very stressed and.
Yeah, at that point of time, yeah. But later on, we heard a news that, and then it fell down. Some people saw the parachute opening. Some people did not see much. So even today, everyone is debating whether the parachute actually.
We had with the team of had a big meeting about what has happened this fateful morning, and concerning the asteroid rotate, we think that just after hitting the cloud, the fairing opened. That's why the bung is. We think the bung is the two fairings just breaking apart from the rockets, because you had a sort of little
solenoid
pivots.
Oh yeah,
The
yeah.
pivots to open it. I don't think they will.
There is more to that story. I tried to get it working.
The probable version from the volunteers that have many decades of experience in launching rockets said that during the fairing separation, the two half fairings were just gone because of the high-speed wind, and the chute probably has covered the rocket at this time. So when the rocket fell down, some people see a big, long string of orange. So we think that the parachute was enveloping the rockets like a long string of the part of the chute. When the rocket fell down, all the drone we had sent didn't see anything because the chute was into the ground with the rocket, because it was like a socket, a socks around the rocket. You may have more detail that you have imagined, no?
Yeah, so I'll tell you for sure what I know is the release mechanism was a solenoid powered by a timer. The timer was connected to the launch pad. There was a jack. There was a launch. There was a timer of I think 10 seconds. And at 10 seconds, solenoid was supposed to release to pivot open and release the parachute was supposed to be released. Now what we suspect, solenoid did not hold up to all that pressure. What
solenoid tends to do.
Yeah, there were discussions, the review of the rocket, whether the solenoid was a very good idea, because we had our doubts.
It's never a good idea. The solenoid from many decades in space is not a good idea ever. At some point, it was the only solution because we don't have cheap affordable servers like we have today.
Yes.
But now.
Yeah. So that indeed is one of the changes we want to make in this year's rocket, because we have an Excel sheet of analysis of what happened with ATREIDES.
I learned that you want to make like asteroid BIS, a second asteroid experiment.
Yeah. What we want to do this year is, because in our opinion, in the collective opinion of this association, ATREIDES was not a very big success in terms of engineering.
But it's something to learn. You are not necessarily obligated to do the same thing.
Yeah, so we want to make ATREIDES part 2, but not do the same things they did last year. So a new rocket in a new way, just so that better, more technical, basically we don't want to make a flying tank this time. And because we cannot let one of our rockets go down in history as, ATREIDES, very bad, very bad. We need ATREIDES part 2, which was a revised. So we have our Excel sheet, we have had meetings, we know what is wrong. So for this year, for example, we want to do a servo mechanism for release of rocket.
You don't want to do a fairing opening this time?
We don't want to do that. We want to do a proper servo mech. We want to do more simulations. We want to have more organization. And this time we don't want to specifically do a timer for the release. We are either going to use an IMU to calculate apogee, or probably one as one of the experiments in ELEC, other than the old experience.
Do you want to have a timer and another solution, or just another solution?
No, a timer for backup and...
Yes. And you work on the software simulation?
The simulations were already done by the time we had come. They were working on the parachute and it contribute more to it, although we would have liked to, because the thing to notice, when we joined CLES, we were first year students.
Yes. Now you have more experience.
Now we have more experience. So at that point of time, we were still learning how to do stuff.
And do you plan to be more, because you're on the project now,
Yeah.
you're on another rocket, but are you taking the responsibilities in the functioning of the club, like the bureau and the...
I'm the vice president of CLES this year.
You're the VP.
Yeah,
You don't want to do like in the United States and become president now? Or
Well, no.
you want to work in space related industry after
Yeah.
your studies? You are in it's 3 years yes, that you had been in INSA?
Yeah.
2 or 3?
3.
3.
This is my 3rd year.
You will work in 1 year?
Well, if I get, I will most probably do my masters after.
Okay. You're in bachelor's?
Yeah.
Okay, so you have 3 years.
3 years of bachelor's
And
and
after you have 2 years of
masters. Yeah.
Okay, I understand. Yes, you're not at the...
Yeah.
Oh, okay. I thought it was 3 years of engineering.
No.
Okay.
That's not us.
Okay, so you have still a bit of time. And another question is, you came to INSA from another
Country?
country?
Yeah.
From which country?
From India.
India, okay. And why INSA in Lyon? Why?
Well, before I came to INSA, I was in India. Not a lot of time there. I was born there in India. Then I went to another country because my father got transferred. And then I came back to India, and then I gave some naval exams. But then I did not make it. So then when I started looking for universities, I found like INSA, found some universities in America. And I found one university in Singapore, NTU, Nanyang. So I got accepted everywhere. So then I had to make a choice. INSA is, as an international student, I can afford INSA.
Yes.
Plus, because France has always been a...
And you didn't know that there was a rocketry association at the time?
No, it's a good, from what I read online, it was a good engineering school. They had a lot of connections like my programs. So it was a good way for me as an international student to get into the aerospace industry. And
I understand.
yeah.
Okay, Bogdan, it's time. It will be a long one.
It's gonna be a long one.
Okay, so firstly, the first thing we will talk is not about that, or that, or that, or that, or even that. How did you come up at CLES?
Alright, so just like everyone else, I came to INSA because it was cheap. And I found out that they joined CLES because at the beginning I was just lost coming to France with getting my life up. You know, you come to a foreign country, things.
Which country did you come from?
I'm from Poland.
Oh, so the guys in Poland, I think, do a lot of things with their hands. It's not a cultural thing to do a lot of things by yourself in Poland.
I don't get what you
I see many people coming from Poland and
Yeah.
doing everything themselves.
Yeah, I
their
would prefer my
table,
own.
normal
Cheaper
thing.
to buy tools than to pay for a mechanic to fix. So I would rather fix it myself. And like I get all the tools. So for example, when I have to change my oil, the next time when I have to change my oil, I will just get the tools. I also have to do the timing belt. So I'm just gonna get tools for that. I'm gonna pay like 100 euros for the tools, but I won't have to pay 200 euros for the labor. It's just, and I know how to do timing belt because there are instructions online, like how to
yes.
do everything. You just follow the instructions. There are even YouTube videos. It's actually easier to find YouTube videos on how to fix your own piece in English.
Because in Polish, it's the mechanics that are many more times more.
Okay, when you become 18 in Poland, your parents are like, get a car, get a driver's license.
Okay.
Every engineering student in Poland has a car and a driving license. When you're an engineering student, what you do, you work on the car.
Okay.
So cars are like, and even like a lot of people want to like become like hobby mechanic. A lot of people do that. It's
Cultural
more
thing.
of a culture. We have like a car culture.
Okay.
Like if you don't have a car, you shouldn't really try dating because you're no.
So any guys from Paris will just go to waste. Okay, it's fun. So that's so when you came up in France, you take your cars with you?
No. I came by train.
Okay.
It was very expensive.
Okay.
And the next time I just went with my car because paying for the highways is cheaper than to just buy a train tickets because TGV is more expensive than
Yes.
fuel. Take the train if I can just take my car.
You have 3 countries, so you have to buy multiple train to.
No, you can get tickets from Deutsche Bank, which is like in the middle.
Yes.
Because SNCF was like 300 euros. Deutsche Bahn said like 100, 120 euros for a ticket.
Oh, it's okay.
So it's just because
So
I burned like 50 liters of diesel.
INSA, and you were like, okay, let's do mechanics, and you didn't go to the racing team.
No, because all my friends came to CLES-FACIL.
Okay, so you followed them.
Yeah, because I mean the car would be fun, but I believe that rockets are
Funnier.
funnier, especially when they crash. Space explosions are the most interesting things about space. I actually love like deep dives into space explosions. I believe it's like
Do you know CSI Starbase?
no.
It's guys in English that do big deep dives on the Starship failures.
I'm not that like I used to be.
Not that deep.
I used to follow Elon Musk everything, but
No.
I got a life now, so
You have more things to do.
I have more things to do, like design these beautiful pieces.
So when you arrive at CLES-FACIL, what did you do first? What was your first project?
My first project was the experience.
Okay, so the
since
flying wheel.
Yes, but since I know how to do like 3D modeling, I know how to do PCBs. With time, I ended up working on
Okay.
because yeah. So when I came to class, we were just like after. So during COVID, we were not able to launch. We had a huge problem that like more experienced members left,
Yes.
and no one got the experience because there were no events during COVID.
Okay.
So when I came, the mechanical part of the rocket was done, but there was no electronics and no experience. So we were told, here is the motor, here is the bearing, figure something out.
So you didn't choose the motor nor the bearing?
The motor nor the bearing. Here are actually like the bearings, and they're way too tiny for a big wheel, like the inner plastic. We had the plastic inside to minimize the weight that doesn't like contribute much to the total inertia of the wheel, because you want the weight to be as far from the center of rotation as possible.
Yes.
So we had like a plastic axle inside, and a metal cylinder would go over that, and it would get clamped from top and bottom to the plastic axle.
Okay, I
Because
understand.
we didn't want a cylinder that would be full like a rod, because then the
Yes.
mass would be close to the center and it wouldn't contribute to the moment of inertia of the wheel.
Yes.
So, and we also were told that the weight budget for experience is 3 kilos.
Yes.
So I opened SolidWorks and I was like, let's make the cylinder, I don't know, like 100 millimeters tall or 120. And I like chose dimensions until I ended up with 2 kilos for the motor, and I figured for the wheel, like 1 kilo for the rest is gonna be alright. So that's how the cylinder came to be. Oh, and actually our first prototype was made from like a scrap aluminum part. We did that design with like a piece of scrap aluminum. It barely worked. These parts were made for the newer bearing, because
You use bigger bearings after
and
that?
way bigger bearings. Yeah. So this was the first prototype, and this is the prototype with that bearings where we had the incident with the key making a hole round. So
Oh,
after
here
that,
you have the key?
yeah, like it would slot into that and it made a hole. So after that, I made like
This key.
I wrote G code for
Okay,
that by hand. Like I never used.
Here you have... Putain, il va pas faire le focus. Here you have the square key, but it will be fucked up by the motor, so we use this type of key instead, with the screw around it to keep it in place in the PLA. Okay.
I didn't want to bother to learn how to use SolidWorks CAM. I wrote G code by hand to make that.
What? Why?
'Cause-
SolidWorks is easy.
Yeah, but it didn't want to cut the outline. Because I
outline.
needed like tabs to like keep it in place. So I was like, I'm just gonna write it by hand, and it was.
And at the time you didn't know Fusion existed.
I knew that Fusion existed, but I didn't want to have some parts in Fusion, then like export step to assembly in SolidWorks. I was just like, I'm gonna design in SolidWorks and then write G code by hand. It's not that hard.
But no, it's a pain just for doing that.
I just like copied like wrote a part. I had sections. Then I would like go in a bit deeper and like copy the section to cut out the certain feature like on it. So it was pain, but it worked. And
Nice.
this year I will probably do more G-code by hand because I just don't want to bother to learn how to use CAM.
Just use Fusion.
But this is like a 2D part.
if yes,
I
but
understand if the part is 3D
in
with the CAM.
Fusion you can just plug your CNC and told it go there, and you don't have to code anything.
Oh, actually, to solder cables to Arduino to get it working.
I don't understand. Why did you?
The PC we had would be driven by like an old PC with a parallel port. Like, you either needed Windows with Mac 3 on it, Linux with like real-time kernel, with Linux CNC.
But
Linux
Linux
CNC is pain in the ass to get working. So
Oh shit.
you would need a single core computer, 32-bit, with a parallel port running Windows XP.
Arduino. You can do that on Arduino?
No, I mean, no, to get like the parallel port working. So I just took an Arduino, uploaded Gerbil to it. At that time we didn't have like the pins you would plug into Arduino. So I just soldered it to the bottom of an Arduino. I still have that, I can like show this. It's my creation.
Ok, d'accord. Bon bah, don't come too far.
I got it.
I need to know if you are still in range for your microphone. Fucking shit.
I have it. So this is a parallel port cable and this is an Arduino.
Illegal. Okay. So you have the best soldering practice, I think. It will be an award here. It's okay. I think we all made stuff like this to make using a fucking.
So this had like
Yes.
and I didn't like the way it, so I just rewrote the G code to make a set.
And in the final.
Yes, it was a set. It was.
How
looked
many
better
points
that way.
did you made in G code by hand?
How many like lines of G code?
Yes.
It's probably like 100 lines
Okay, well, everything.
for everything.
Oh, okay. So you
It was
it's
very.
okay.
And just most lines were reached. I
Yes.
went like in the incremental mode.
Oh, yes.
So I just told it to like move this distance, and I would just
Okay.
the Gerbil doesn't have like loops in G code, so I wasn't able to make a loop. So I had to make like a path, and if I wanted to repeat the path at different depths, I would have to like change make it go in, and then copy paste the previous
Keshav.
Yeah, I had like a problem with feed rates because in G code, if you don't put a dot after a number, I think it's the units in the correct way. So like I put the code onto the CNC and it's not moving. It turns out that my feed rate not 100 millimeters per I don't know. I just plugged in random numbers to see like how fast it would move. I had like 100 or something there. And if there wasn't a dot, it would be like 100 micrometers per second or something.
Okay.
And if you put like normal 100, it's like 100 millimeters. I don't know. It's no way. It wasn't 100 there. It was like 10.
Okay. You made your first tries and your first bearings, and between this first prototype, but I think it was the first,
It's actually like 4th or maybe even 5th.
But you passed from that to.
So we had like the thing is we needed the shaft of the motor to go through the bearing.
Yes.
So bearing didn't leave much space inside for like the plastic to attach it.
Yes.
So
You needed
the
more.
plastic just broke. So
Yes.
then we were like, let's get bigger bearings. So we wanted like tapered bearings.
Stability.
Yeah. Then we saw the price.
It's
and
not
then
cheap.
we were like, I mean, these are quite cheap. These are like 10 euros. But
It's not cheap for bearings.
I mean, it's not cheap, but it's cheap for a rocket club.
Yes.
Then I wanted like a 60 or 80 millimeter big one. Grab the price and it was like more than hundreds of euros.
Okay.
So then I was like, a ball bearing cannot be that bad, right?
Actually, if you choose the good one of the ball bearings, it's not the balls that hold up in place. It's the plastic things that are outside it. Things can be done so that you have not a tape rail like this, but you have some sort of overlap, like some of the plastic
Yeah.
are up, some are down. Something that you want to center, it auto-center the thing.
Oh, so
But it depends on the
we
type
just
that
got
you got.
deep groove ball bearings.
Yes, okay. So
where,
so
like,
that
the
you
groove
have...
would be like offset, so it would technically.
That's-
Yeah.
Okay, I know. Oh, yeah, yes.
But they were €5. So we should
And
have, we should have
how many
gotten-
millimeters of...
Like the bearing was like I think 70mm wide.
Ah ouais.
So this is like the inner the bearing.
Ah,
So-
so it was here. Here you had the bear.
and the outer diameter would go on the inside cylinder.
Here.
I think all of my prototypes got thrown out because it was like a big box.
Yes, yes.
I think it's like 7 kilos of plastic.
You don't need to infill.
It's not printed by me because I used 5% on everything because I was like, if it didn't break,
It's okay.
it's okay. Why would I give it more infill? Especially since I'm making a prototype. I wanted prototypes fast.
Yes.
But these were final, and I don't know why they have 100%
Percent,
infill.
100. You
Like, I
like
feel
2
sorry.
days of printing.
I feel sorry for the person who had to, and look at the layer height. So I feel sorry for persons because it wasn't me. I think it's like fine detail.
Oh, fuck.
I think it's like 0.1mm layer height or something.
Oh, fuck.
So like I wouldn't be surprised if this took like 1 day to print.
Oh, shit. Okay.
I mean, I understand that of the part increases with like decreased layer height, but I don't think you don't need to do it.
You
that
don't
much.
need a one to have something.
Yeah,
Eh.
and also my original design was like quite slimmer. Like here they like increased it to
Thickness.
the thickness because I sent like a file where this part, the outer ring, would be thicker and like the inside would be like a bit like more like thinner
Yes.
because
It didn't need to be that thick.
the thickness of the outside was only meant to make it center in the fuselage.
Yes, so why?
Yeah.
Okay, so you have big blocks of plastic that if
That-
you need to recycle now, then because
I
of
mean, I don't. There is a bin for plastic. There is no like filament recycling services.
oh yes,
I mean,
yeah.
we were thinking about getting like a filament recycling machine, but they're so expensive.
Yes, but you have recycling firm, but it's a donation you give.
Yeah,
anyway,
the
you
trash bin outside is also a donation.
you shit the amount of plastic.
But
After
they
you had
recycled the insert.
nah. So you yes why no no okay.
Yeah. So
But when you had this final, you have like your metal part was just a tube around it.
like the how do I show it? Like this this was to like attach it into in the fuselage.
The
Like
fuselage.
an
Oh yes.
Axle would
Okay.
go over it. The cylinder would be around the axle, and then there would be another one to like hold it from the top.
So you would have like this and the bearing top for
Yes.
the
And
for
there's-
centering the motor.
Yeah, and there's one with like bigger hole that had just the bearing, and the one with the smaller hole had the motor.
Okay, so okay.
And like a motor had a key attached to it that would like connect it to like the shaft.
Okay.
To the axle.
So you and the axle was 3D printed in the inside of
It was 3D printed with aluminum insert to hold
To
the shaft
hold.
in place.
and the 3D printed thing will also be with the bearing.
Yeah.
And then you have, we will again, you will
Yeah.
have the wheel. Okay.
Yeah.
I have some picture of your wheel in my camera, but
And I have the design on SolidWorks.
okay.
So,
So you will have that, and you have the motor on top or on bottom.
I have no idea because my job was to just make this. How it goes inside the rocket, that was like mechanical team.
It's not my problem.
Okay, I just gave them where I need holes. Their job was to put it inside
But
the
you
rocket.
also tell them that you need to have place in. No.
Yeah.
Okay. It was on top, but I don't know if it's the best
I
thing
think
to have it on
It
top.
was on the top we had like the parachute that was like opening.
No,
Under
because
that
no,
we
no,
had
no.
electronics.
Your wheel is on the center of gravity, so it's way below your.
Yeah,
chute.
I think it's down, and the motor was
Facing up.
like the motor was like here.
Okay.
In the test bench, we ran it the other way around because it was easier, but in the final rocket, it was rotated.
Okay, so you had this and all your electronic parts and your battery. You use the battery?
Yes.
The big,
the
big fat and your yes. We have something to talk about the battery management system too.
What's that?
Okay, that's a problem.
I know what's that. Okay, the VESC will turn itself off if the battery falls below a certain voltage.
Yes, but
So that's all we did.
yes, but the problem is that Planet Science allows that. You need to have something that is on your battery to manage it, and the thing is when Julie was talking about it, she was like, "We need a BMS." I was like, "Yes." She was like,
Yeah.
"Oh!" So we designed the BMS for her because with really fixed solenoid, really fixed relay, I think.
Yeah.
But the hard part is that your battery was so fucking huge that designing a BMS that can allow to flow all your current was like,
Okay, the
oh
battery,
shit.
the battery was rated for 60 amps,
Yes.
and we were running 8 cells in a series. But we were not actually running. We were running more at like 300 because we had a very badly chosen motor. Because our motor was for racing, like tiny 1 to 8 scale racing cars, not that much torque, so we just think we'll get a bit more torque. It's
And
not
a bit
it's
more
not like
fried motor too, but yes.
It didn't. If you run it for 10 seconds, it can handle
Yes,
300 amps.
yes.
The connector amps, and they handle. Because when we tested, I was like, okay, why not put 300 amps and see what happens, like what burns, and nothing burned.
Like, oh, okay.
I mean, the 60 amp
But
connector is
did you
good.
know that? Did you put a sensor to know how many currents was?
The
doing?
sensor is built into VESC. So
And he knows that 300 amps is flowing through it.
yes,
Okay.
because we bought like a special €200 VESC that could handle. We had to get it from China, like a knockoff, because the original one would be like €700.
Oh fuck.
But this year we're gonna use like a motor for drones for
Yes.
agriculture.
It's easier to have. For our rocket we used a motor that was not designed for drone, but was designed for heavy duty robot gimbal.
Yeah.
And this shit was absolutely tearing you off if you didn't pay attention to it, and it was this size.
Ooh. So
With a
we're-
big advantage that it has a hole in the middle for passing through the cable.
Ooh.
And this was fucking
So
insane.
we're getting a motor that is able to lift 30 kilos.
Nice. Yes. At
So-
1 meter. It's 30 Newton meter, your motor.
Yeah. I
Oh.
mean, no, the lift. So the motor doesn't have 30 Newton meters. If you attach a huge propeller to it,
Okay.
it will be able to lift 30 kilos.
Okay.
Because
Yes.
we're getting a motor for drones,
Mm.
but since they want efficiency, they have big propellers
But you-
that rotate slowly. We're getting used because these drones crash all the time.
Yes, but what is the price?
Like €80.
Our motor was 80 euros. The new one.
New
But yes, the newer one. It's a T-motor, K90 motor. T-motor for gimballing system and robots. But the only thing, you have to solder your wire to the motor. And I fucked the connector up on the first, so we need to buy a new one. We needed to buy a new one, and the problem is that it's a fucking cheap connector. That you have to solder it. When the soldering is done,
Yeah. You have
The-
to wait a minute till the.
no, it's not that. I added for the second try a big glued belt so that nothing moves, and I put some 3D print on it to make sure that everything was tight and secured. And I was like, okay, this time we don't have a problem with, because the problem is that if you connect it and solder it, you're like, oh, it's fine. No, the fucking pads, it's just retained by some small wire behind it, so you can disconnect it. Sorry, it's not about me, but I think you will be more serene about your talk if you use a robot gimbal.
I mean, we still haven't bought it yet. 'Cause
Yes.
it's the beginning of the year. We spent all of our money last year, so now we have to like figure out where to get money from so that we can start buying. But
Yes,
it's always
always a
like
pain. Yes.
we ask for like 10,000 euros.
You have?
Because the more we ask,
The more
we
you,
get.
but you don't get
Then
10,000.
we get like 300.
Yes, but you. How many? What is your typical budget?
Our typical budget, I think, is around 10,000 euros.
A pretty good budget. You can make rockets with 10,000, I think.
Yeah, the last rocket was like 5,000.
Okay. Okay.
And the last rocket was like 5,000, but we also had to buy a lot of tools like the CNC for us, because the thing with the access to tools is very, very, very problematic. Because we have a fab lab at the campus, but it's more for like artsy students,
Art? What?
like to make art. They have like a really expensive water jet cutter. It's made for like art people, so you have to like submit your designs on a web page. It's very beautiful, but it's extremely slow and it's extremely expensive.
Why? But why?
They also have like very tiny 3-axis CNC machine, so it doesn't really help us. And so there are better labs, but they're just for like, you know, teachers at the university. Getting access to manufacturing is just pain. And it's funny that like our lab here just like art, you cannot do like hardcore mechanical engineering there.
Why? And I think at some point when you just do the mechanical thing to do, it becomes hard. But why can't you just use?
I mean, the thing is that we gotta use CNC. It's easier to just wire up some cables and write G-code by hand
Than to go there and have a fucking
go there.
design.
We need to do like a training session on how to use it. The training sessions, you need to like sign up for them. And then the water jet cutter, it's like a very fancy machine that is very shit. It has like a very low water pressure.
Okay.
So it needs a lot of time to cut anything.
Okay.
And it uses it to cut anything.
Okay.
I don't know the brand.
No, you don't want that
I just
anywhere.
uploaded my design and it was like 1 hour and I was like, what? Like 1 hour?
You can use it. You can use it on the night.
No, it's closed during the night. It's only open like
Okay.
8 a.m. till 4 p.m.
Okay. And so your design of all your parts and everything you have done for the things stopped when you had the VEX, the battery, the big metal part.
We had all the mechanics done. We had everything spinning. We wanted to control the reaction wheel through the VESC because it has like software built in for balancing like one-wheel skateboards.
Okay.
So the first VESC we bought had like the inertial sensor built in. The second one we got from China didn't have one. So all we needed to do was like pick up on the VESC. We got that to work and then it fried. For some reason, I don't know why. Like it was reading the data from the sensor fine, and then one day it just stopped working and never worked again. So something got fried. We had huge problems with Hall sensors because they would work, and then a week later they were fried. So we had plenty of fun with getting the VESC to work.
And then when everything worked, you just say, okay, not my problem now to integrate it, and go to
integration. The planning was that I just do mechanics.
Yes.
So I was like, I did the mechanics. Thank you very much for your cooperation.
Goodbye.
Spinning, it was like assembled in a test bench. All needed to be done was like the electronics and like integration to the final rocket. So I was like, thank you.
And this is it. Work's done, guys.
I mean, we lost the whole thing, so I have like nothing to show.
But
like,
what is?
Just before they launched, they were like, it doesn't work. What do we do? I was like, take a wire cutter and just remove it, the VESC, because it was like 200 euros. And I'm kind of mad that they just didn't cut it out of the rocket.
Oh, you let it put. So you had lost the VESC. It was still in the rocket because it needs for balance. Yes, and it was
Yeah,
200
but
euros.
it wasn't that heavy. So you can like put in something else, like a piece of metal or something to just replace the weight. Yeah, so I'm kind of salty about losing 200 euros on a rocket that crashed. Because it didn't even run. Like every time classes finish, I would just go here, eat, and then work.
And what you made me show that.
Yeah.
What is that?
This is the nose cone. So
A prototype.
the prototype.
Okay.
Like it's like Mark II prototype. I think there were like 4 prototypes of that. The first prototype have any mounting hardware for the solenoid. So,
And you
I think
still
it
use
was-
the solenoid on this prototype.
yeah, and this is for 50% infill. So here once, and I saw that they were struggling to get it working because the solenoid just refused to work. There were multiple problems. First, when we applied the rated voltage, the force it had was just too small. So what would happen if we doubled the voltage? When we doubled the voltage, it worked fine because the limit is the solenoid overheating.
Yes.
But we're not running it for long periods
Yes,
of time.
yes.
So the timer worked that after programmed amount of time, it would just turn on the solenoid to open it for 5 seconds and then turn it off. So we were like, nothing is gonna happen if we run it at double the voltage for 5 seconds.
Yes.
So then there were multiple other problems. Like we had like a plunger inside the solenoid, and in this design, the solenoid was too far from the plunger to like pull it.
Yes. Pull the plunger
So
to
we,
mechanically
used a
separate.
Dremel, this place to get the solenoid as close to the plunger so that it was able to lift it. We had another problem that the plunger just there are like holes through the inside. So we assembled it like this. We applied voltage while assembling so that the plunger would be kept inside the solenoid. The voltage and it falls out through this hole. So
Okay.
that's why there is a piece of tape
To block it
to
from
block it.
falling.
Another problem was that once this was closed, we would have springs here to
Push it.
push it open when it's supposed to open. But the thing is, if we in the beginning we used a spring that was quite strong, so the friction against the plastic here
Was too much.
was too much and it wouldn't open.
Yes.
So we had to find a perfect spring that would be strong enough but not too strong.
Yes.
And the solenoid was just pain in the ass to
Yes.
get working.
Because
Like, it
solenoids is
refused.
too fucking complex. If you had a servo, it will be easier.
And I had to abuse a step-up converter because
You need to step up.
Because we had just 12 volts, applying more like 28 the solenoid. So everyone was like, "What do we do? How do we drive it?" So I had a
Step up booster.
a
Yes.
step-up booster, the cheapest Chinese, XL6002 or something. So we were like, okay, we have the voltage source, but how do we turn it on? So then I went into the datasheet and I found that the chip has a on-off pin that was connected permanently to, I think, ground on the PCB or power to it's permanently on. So I unsoldered it and lifted the leg of the chip and connected it to the cable. And the first boost converter I did it on ended up in the final rocket that crashed.
Okay, nice.
We
You
reused
successed on
it.
the first try.
Yeah, because the first prototype for the timer, actually it wasn't for the timer, it's just that we needed something to test the solenoid before the timer was done. So I just took a prototype board, I soldered an Arduino Nano to it, and the boost converter. I found a 5-volt LDO somewhere laying around in the scrap to get 5 volts from the 12 volts. It didn't even have capacitors on the input or the output of the LDO because I just didn't bother with it.
Okay.
Okay, you don't need capacitors on your power system to work. You just need it for the system to work well.
It's for having a nice, not fluctuating DC
yeah,
power.
but
But if you don't need
your
nice
PCB
fluctuate,
but
nice not
PCB
fluctuate.
is a capacitor,
But
a
yeah.
very small one, but it works.
But if I think I need to go now. But
Alright.
it was very interesting. If you had anything else to add for your crazy experiment, because I think you're more here to experimenting than rather than doing rockets. I think.
I mean,
I think you're having so much joy doing what you do, no?
yeah, I just do random things and
It works.
it works.
Okay. So thank you. I think we talked a lot and diverged a bit, but I saw things to show. Thank you.
Yeah, you're welcome.
And hope to see you at Space this year.
Ok, moi du coup c'est Zacarias Mbaki, je suis originaire d'Angola. Donc, je suis arrivé en France en 2019. Et après un IoT à Metz, j'ai agressé l'INSA en formation par apprentissage, génie mécanique, génie CIP.
Ok.
Génie mécanique ou section.
Et donc, la raison pour laquelle tu es arrivé au CLES-FACIL?
Oui, c'est parce qu'en fait, je me fait un peu ennuyer au club IRT, donc c'est le club qui fait des voitures de course. Et j'ai cherché quelque chose, ça serait beaucoup plus intéressant. Et je me suis dit, voilà, il y avait les PS juste à côté, et j'aime bien aussi tout ce qui est espace, aéronautique. J'ai eu l'occasion de continuer à apprendre et progresser dans ce domaine de compétences, qui est d'ailleurs le domaine dans lequel j'aimerais bien travailler dans le futur.
Ok. Donc, t'es plutôt passionné lanceur?
Ouais, plutôt lanceur, ouais.
Et du coup, sur les différents projets que tu as fait au CLES, peut-être sur la partie méca et élect?
Ouais, je vais essayer de pas travailler sur ATREIDES parce qu'ATREIDES il était déjà bien avancé au niveau mécanique. Donc on s'est décidé de se lancer sur le Hyperion, qui est la fusée qui est là, que je l'ai conçue avec Alex de A à Z. Donc on a réfléchi à différents concepts de cette fusée-là. Et voilà, c'était la première fusée que j'ai fait. Et là-dessus, j'ai travaillé sur toute la partie concept. Donc Alex, il faisait beaucoup de la CAO et moi, je m'occupais de la fab et de toute l'électronique. C'est moi qui avais conçu le PCB pour Hyperion et j'ai aussi fait la formation du séquenceur Arduino et la fabrication aussi. Donc on avait fait quelques fabrications pour la plaque graph, c'est moi qui l'ai imprimé en 3D, l'assemblage de la fusée. Et en deuxième année, j'ai décidé finalement d'intégrer ATREIDES pour la partie expérience, mais plutôt la partie commande, qui était la partie qui n'a pas été bien aboutie jusque-là.
Parce que du coup, t'étais en méca.
Ouais.
Et t'es allé en partie
Commande, contrôle, ouais. Parce qu'en fait,
loi de contrôle, pas
non, pas électronique, c'était plutôt loi de contrôle, ouais. J'ai fait quelques cours pour les systèmes linéaires que j'ai décidé, c'est plutôt sur ma passion pour ticket. Et c'était un peu fort.
Alors pourquoi?
Parce qu'en fait, c'était hyper compliqué à gérer la partie contrôle, puisqu'en fait, on a mis un RESC dont Keshav et Clément ont dû parler. Sauf que le VESC, il y avait un environnement qui était pas bien fait. En fait, tu devrais régler tout ce qui est consignes et correcteurs dans leur environnement. Et c'était pas si simple que ça, en fait, de gérer tout l'environnement, de pouvoir paramétrer tout l'ensemble. Parce que déjà, le moteur qu'on utilisait, il n'était pas adapté à ce qu'on voulait faire. Et on s'est rendu compte qu'en fait, on avait plein de soucis. Il avait un million de façons de gérer la partie contrôle. Et avec qu'est-ce qu'on voulait faire, en fait, ça marchait pas trop. C'est pour ça que c'était pas un bon choix de...
Et vous n'aviez pas aussi de simulation qui allait avec ça?
Alors, on n'avait pas du tout fait les simulations pour l'expérience numérique. Ce qu'on faisait, c'est vers la fin, on essayait de le faire sur place. Donc, on prenait le volant, je prenais le volant, je le mettais à table déjà pour pouvoir juste avoir une lecture de l'accéléromètre extérieur par le VEST. C'est la première galère, donc ça nous a pris trop de temps. Et ensuite, passer à l'étape d'après, qui serait par exemple juste avec l'accéléromètre, le gyroscope dans la main, essayer de tourner, voir si le moteur compensait ses rotations. C'était aussi hyper compliqué. Je me rappelle de devoir faire appel aux gens du club LA qui eux non plus, ils ont galéré, ils ont dit pourquoi vous utilisez le VESC et tout ça. C'était le seul choix qu'on a.
Donc en fait, si vous devez le refaire, ce que vous faites cette année, vous ne prenez pas de VESC?
Non, peut-être la boîte, oui, mais c'est ça c'est à discuter. C'est des choix qu'on a déjà discuté avec Bogdan. Mais surtout pour le moteur, je pense qu'on va devoir changer ou peut-être faire même un contrôleur nous-mêmes. Donc on utilise un Arduino.
L'avantage de faire un contrôleur toi-même, c'est quand même que tu as plus de liberté.
De flexibilité, oui, c'est ça. Alors que les VS, t'es figé à un environnement, tu dois faire avec ce qu'ils ont. Et souvent, c'est pas facile à faire.
Mais du coup, vous aviez pas non plus pensé à faire ce qu'on avait fait sur notre volant d'inertie, qui était assez spécial. C'est qu'on avait pris en fait, sur notre stand de test, on avait fait un step. Le step nous donnait une réponse, du coup.
Ouais.
Et la réponse, c'est la réponse naturelle du système. Et à partir de la réponse naturelle du système, on a généré un modèle. Quand t'as une réponse naturelle d'un système, et que tu supposes qu'il n'y a pas de perturbation, bah en fait, tu peux générer une fonction de transfert qui correspond à ton système réel.
Ok.
Et comme tu as une fonction de transfert qui correspond au système réel, ta fonction de transfert, c'est dans ta simulation, ça devient le système, et tu peux créer une boucle de contrôle autour.
Même si tu prends en compte les perturbations.
Ouais.
En fait,
les perturbations, c'est en gros quand tu fais ça, les perturbations, c'est en gros c'est ce que va voir ton capteur en entrée.
Ouais.
Mais comme tu vas la corriger avec ton contrôleur que tu vas générer après par le biais de ton système réel, dès que tu as ton système réel simulé, ta fonction de transfert en fait qui est en gros ton système simulé, tu peux générer une fonction de correction sur MATLAB. Je crois que tu utilises MATLAB.
Simulink.
Et avec le PID tuner, tu fais un truc nickel. Et en plus après, quand tu as le PID tuner, l'intégrer c'est encore plus cool.
C'est peut-être un sujet à discuter. Hein.
Sache que si vous avez besoin d'aide là-dessus, n'hésitez pas. C'est pas moi qui l'ai fait. C'est un collègue à moi.
Vous avez des documentations sur votre tour d'inertie? Parce qu'en fait, on a
sur Sky, il y a plein de rapports. Hein. N'hésitez pas.
Ça s'appelle comment après à la fin? Je peux me dire le site parce qu'on a déjà commencé à réfléchir.
Oui, ça m'a la fusée.
Ok.
Et c'est l'année dernière. Elle a fait un joli looping à cause du moteur.
Et le contrôle.
Merci, on l'avait testé avec la fusée. En fait, on l'a suspendu sur des étages de bearing.
Et ça a bien marché?
C'était incroyable.
Et dans la vie réelle, ça a marché?
Ça a vraiment bien marché dans la vie réelle. Parce que on était là. Franchement, la fusée, en fait, la fusée, on l'avait dit, ok, le moteur s'allume pour faire tourner la fusée à une certaine vitesse. Et en fait, le but, c'était de se dire, ok, le volant d'inertie met à tourner la fusée à telle vitesse, et puis au moment, il doit l'arrêter net. On lance le contrôle, tu vois.
Ouais.
Et on était là, on l'a suspendu dans la cage d'escalier de notre parce que j'étais en stage, donc c'était à Paris dans un HLM. Et là, tout d'un coup, je vois la fusée qui tourne, et puis, arrêtez net. La fusée, elle fait, stop.
Et nous, on avait essayé de faire.
Et on était là en mode. Et en fait, c'est à ce moment-là qu'on s'est rendu compte que notre contrôleur,
il marche bien.
Il est parfait.
Parce que nous, on avait essayé de faire la même chose, sauf que nous, la fusée, elle partait dans le sens inverse.
Oui, parce qu'il faut mettre un moins.
Ouais.
En fait, non, on a fait la même connerie. On était en mode, putain, la fusée, elle part en couille. Oui, parce qu'en fait, le contrôleur, il est en train d'essayer de corriger, mais il va dans le mauvais sens.
Il faut mettre un.
Et du coup, on a mis un moins devant notre fonction de contrôle de PID, parce que du coup, là, on fait une fonction de transfert total, ça mettait tout dans le négatif. Et on était là en mode, bon, on met un moins dans le contrôleur. Et à la fin, ça s'arrêtait net.
Okay.
Et on était là, on était fatigués, on était en mode incroyable. Alors on a une vidéo que j'ai mise sur YouTube d'ailleurs où on me voit réagir. Bon, c'était un peu un reenactment, c'était un peu un jeu d'acteur. Parce que la vraie fois où on l'a fait, j'étais torse nu en claquette et j'étais en mode oh bordel de merde, on a enfin réussi, regarde. Et donc je l'ai refait juste après avec un t-shirt. Ce qui est quand même, je n'avais pas non plus déconner. Voilà. Mais
on espère que cette année, on va réussir à le faire.
Et si vous voulez l'être sur la partie contrôle, n'hésitez pas.
Ouais,
Nous, on a même des preuves, parce que le vol a duré 16 secondes, parce qu'il s'est crashé. Mais on a des preuves qu'il a bien fonctionné durant le vol aussi.
Ok.
Donc, si vous voulez étonner et de l'aide, n'hésitez pas. Hein.
On avait essayé de voir un prof spécifiquement sur ça. Et le prof, il disait qu'en fait, contrôler le roulis par un volant d'inertie, c'est pas tout à fait une bonne idée. Parce qu'en fait, il disait que quand la fusée il est en plein vol, les perturbations qui visent à le faire tourner en roulis, il est pas, c'est pas des perturbations, c'est quoi le bon terme? C'est des perturbations plutôt permanentes, en fait.
Oui.
Pas des perturbations ponctuelles.
En fait, ça marche que quelques secondes.
Oui. Et du coup,
si tu veux faire une fusée, tu vois, qui vont dans l'espace, personne n'utilise contrôle de roue.
C'est ça. Ouais.
Ça marche bien quand ta fusée, elle a 30 secondes de temps.
De vol, c'est ça.
Est-ce qu'au bout de 30 secondes, en fait, il a raison, c'est que en fait, c'est l'accélération de ton volant qui fait la correction. Sauf que bon, au bout d'un moment, tu peux plus accélérer.
Ouais. Et pour vous, le volant, il commençait à tourner dès que la fusée montait?
Non. T'es obligé d'ailleurs, votre système doit être inhibé avant la fin de la propulsion.
Ok.
Donc c'est un timer. Nous, en fait, d'ailleurs, nous, vu qu'on n'arrivait pas, on avait des problèmes pour le faire démarrer parce qu'on avait un moteur très faible. On s'était dit, on va sous-dimensionner maximum le système. La fusée faisait 6 cm de diamètre seulement. Il y a une fusex. Le volant faisait 5. Il était creux pour faire passer les câbles au milieu. Le moteur était en dessous comme ça quand on le poussait de la fusée, parce qu'elle allait très haut, du coup la fusée elle allait à 3 km. La poussée de la fusée faisait en sorte qu'elle passe sur le moteur et elle se déloge pas du moteur, tu vois. Et le moteur, j'ai fait une série de vidéos là-dessus.
Ouais, j'aimerais bien.
Et en fait, le moteur, on a un problème, c'est que quand il démarrait, il avait tendance à le décrocher. Donc, en gros, il tente, sauf que comme il est accroché à une masse de 5 kilos, ouais. Une masse de 5 kilos d'acier, bah, il n'arrive pas à tourner, du coup, il s'arrête tout seul. Donc, en fait, le correcteur, avant de se lancer, on a un programme, on a une section du programme qui dit à la fin de la poussée du moteur, tu lances la roue d'inertie en regardant de quel côté la fusée tourne, et il lance une rampe, en fait, une commande de vitesse qui va accélérer la roue dans le sens qu'il faut,
Ok.
pour que ça arrête le roulis. Et une fois qu'il a fini la rampe, il passe en mode contrôle. Parce que vu que la roue est lancée, il peut accélérer, ralentir, et il a moins de chances de décrocher, tu vois. Ça, on l'a fait. Ça, on a réussi à le faire parce que on avait réussi à faire marcher le système de roulis 2 mois avant le vrai vol.
Ouais.
Donc, on avait le temps de faire nos tests et de se rendre compte que, ah, là, ça part, ça s'arrête. Bon, on va ralentir. Hein.
Non, là, j'ai un peu le même problème des décrochages. Et c'est ça qui nous a fait cramer notre capteur AFL.
Comment ça crame?
En fait, c'est toute une question parce qu'en fait, elle avait une grosse masse accrochée à lui. Ça faisait Bogdan. What was the weight of the wheel?
2 kilos.
2 kilos only?
Seulement? Ok.
Only.
Ok.
Et du coup, on avait 2 kilos et le moteur, si tu mettais pas assez de courant, il avait pas fait. Ça faisait clac, 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 clac. Et du coup, c'est ça qui a fait cramer
Ça décroche.
le
Ça
capteur
crame
AFL.
le capteur.
Oui, ça nous a fait cramer le capteur. C'était étonnant parce qu'en fait, on avait typiquement, je sais pas si c'était de la malchance, en fait, ça marchait une fois sur deux, le capteur AFL. Des fois, il te disait et il les reconnaissait pas quand tu voyais sur les programmes. Des fois, il te disait, il y en a, des fois, il y a un temps qui a passé toute la journée, ça marchait pas. Moi, j'arrive le soir, ça marche. Des fois, je passe toute la journée, ça marche pas. Il y a un temps qui arrive le soir, ça marche. C'est comme, on se disait, qu'est-ce qui se passe?
J'ai une question bête.
Ouais.
Le câble du capteur, est-ce qu'il passait à côté du câble du moteur?
Il était tout à l'intérieur, en fait.
Ouais, mais le câble.
Alors, ça, c'était toute une question. En gros, le capteur AFL, il était intégré dans le moteur. Et non, c'est qu'on branchait, tu avais juste 3 fils qui sortaient du moteur, 3 gros fils,
Ouais.
et on connectait au VESC.
Ça, c'est
Donc,
normal.
vous ne voyez pas des câbles du capteur AFL à l'extérieur. C'est un peu compliqué, ouais, c'était ça.
Mais comment c'est possible?
Ouais, je sais pas comment ça a été fait, mais on a le moteur là-bas d'ailleurs. Hein. On a un moteur, un exemple de moteur.
Mais du coup, vous changez pas le capteur, vous changez tout.
On change tout. En fait, c'est ça qui nous a dû arriver. Parce qu'à un moment, je pense que c'était un jour avant d'aller au C-Space, on avait cramé le capteur AFL, donc on ne pouvait plus utiliser le moteur. On a dû acheter un autre pour vite fait sur le bon coin. On va nous dépanner. Donc je me rappelle, on avait trouvé un sur le bon coin à Lyon. Et j'ai appelé le gars et le soir, content, est allé chercher. Donc on avait eu, et Alexandre aussi, il est président, puis a retrouvé encore un nouveau truc. Et c'est ça qui nous a permis d'aller au C-Space. On a trouvé des moteurs qui allait bien. On a dû ressouder le câble sur le vest. En fait, le vest, il était bon, c'est juste le moteur, on a dû tout refaire. Ouais, c'était la partie la moins simple du, bon, mis à part les efforts que les autres ont dû faire pour la partie méca et lait, je pense que l'expérience était très galère aussi. Ouais.
Ouais, ok. Ouais, moi j'aurais dit que c'était parce que vous aviez mis vos 3 câbles à côté du capteur, mais vu qu'ils m'ont même pas au VESC, je sais pas comment fonctionne le capteur.
Cette année, on réfléchit si on refait la même pour la Fusex ou si on refait la même expérience sur une Minif pour essayer de démontrer que ça marche. Et...
Moi, je vous conseille de partir sur une Fusex parce qu'une Minif, vous verrez rien, c'est un vol trop court.
Ouais.
Par contre, prenez que des trucs que vous êtes capable de programmer de A à Z. Genre, Tinsy, c'est la vie, les contrôleurs qui vont à 400 MHz. Le machin, il te compte les nanosecondes. Et il est là en mode, il se passe des choses. Ok. Pour lui, une Tinsy, ça va presque 15 fois plus vite qu'une Arduino. Ça peut voir quand tu appuies sur un bouton, ça voit les rebonds de tout le bouton.
Ok.
Sur des nanosecondes, c'est capable de faire des calculs de correction. Et nous, on utilisait l'Intelli sur
Ce programme en C.
en Arduino. classique.
Ok.
Et on a installé un truc qui est très connu qui s'appelle Chibi RTOS. C'est des RTOS, je sais pas si tu sais ce que c'est. RTOS, c'est Real Time Operating System. C'est-à-dire que c'est un système, c'est une surcouche sur ta Tinzi qui fait que tous les processus que tu lances, le temps d'exécution est défini de manière fixe. Ça veut dire que tu sais, t'as ton temps de réaction
Ouais.
dans tes systèmes. Bah, c'est le temps que tu dis, bah, ma boucle de contrôle, c'est tel bout de programme, je veux que tous les 10 millisecondes, elle fonctionne. Et du coup, ça veut dire qu'elle va fonctionner pendant 10 millisecondes.
Secondes.
Et elle va faire ça de manière régulière, tout le temps dans le temps, sans jamais se foirer.
Et c'est ça que vous avez utilisé pour votre.
Ça marche très très bien.
Ouais,
Seul problème, ça n'aime pas les cartes SD.
Ok.
Parce que les cartes SD, ça met. En fait, c'est des cases mémoire. Quand ça change de case mémoire, ça prend beaucoup plus de temps. Du coup, en fait, dans Chibi RTOS, tu as toute une sous-section réservée pour. En gros, tu as des threads par fonction et tu as des threads réservés aux cartes SD. Parce que les cartes SD, je sais pas comment ça marche, c'est de la magie noire. Donc, si tu veux réussir à enregistrer tes données, tu dois pouvoir les bufferiser dans un thread spécial. Et putain de merde, heureusement que c'est déjà prévu par le gars qui l'a créé.
Ok.
Parce que bordel, on était là en mode comment ça marche? Je sais pas, mais ça marche. Mais quand on l'utilisait pas, en fait, ça plantait toujours notre système. Ah ouais. Ces cartes SD, c'est juste casse.
Vous avez utilisé un gyroscope pour mesurer la. Ok. Bah, du coup, c'est le classique, sauf qu'il y en a.
J'ai eu 92,50.
C'est exactement le même qu'on avait.
Et la Tinzi contrôlait un ESC en PWM directement. Et du coup, elle faisait tous les calculs nécessaires. En plus de ça, elle gérait la TLM, l'expérience, elle faisait plein de trucs en parallèle.
C'était une seule carte que vous avez utilisée pour.
Une Tinzi, ça fait ça.
Elle contrôlait à la fois l'élec et l'expérience.
Ouais, elle contrôle. En fait, la partie télémétrie de ATREIDES est en haut, c'est l'IMU. Et la partie du bas, le volant d'inertie. Nous, on avait tout sur une Tinzi.
Ok.
Une Tinzi, c'est un cœur à 400 MHz. Et d'ailleurs, si tu veux faire des trucs plus compliqués, tu peux aussi prendre maintenant les Raspberry Pi Pico, qui ont 2 cœurs à 120 MHz. Et ça coûte 1 € une Raspberry Pi Pico.
Sur AliExpress.
Ouais. Et puis t'as aussi les ESP32 qui sont à 120 MHz et qui ont 2 cœurs et qui coûtent 5 €.
Mais l'ESP32, c'est que Bogdan avait proposé du coup cette année.
Très bon choix le ESP32.
ESP Fusée. Voilà, donc cette année, on espère que ça va marcher, du coup, l'expérience.
Bah, bon courage. Et du coup, tu seras toujours sur la contrôle.
Alors cette année, j'ai beaucoup travaillé sur la partie méca parce que vu qu'on va devoir refaire toute la partie, donc j'ai beaucoup travaillé sur la
plus léger.
conception de la fusée et la fabrication aussi et la partie contrôle. Pareil, donc je pense, mais plutôt load contrôl que choix de composants parce que je suis un peu nul en tout ça. Et peut-être pour plus de faire des simulations, plutôt commencer par des simulations, par des modèles Simulink et après intégrer ça dans la vie réelle.
Ouais.
Et réfléchir aussi à une manière de le tester parce que le bon test ici, c'est
le meilleur test, c'est votre fusée.
Ouais.
Et nous, ce qu'on avait fait, c'est qu'on avait pris les vis de la coiffe, tu sais. On avait suspendu des fils avec un support au-dessus et c'est là que tu avais le train
pareil.
de bearing. Et quand tu fais ça, bah, ta fusée, elle a exactement la machine inertielle.
Ouais, c'est ça.
Et donc exactement les mêmes réactions, tu auras une fonction, le même moteur, le même système.
On va réfléchir à ça cette année, du coup, à la façon dont on va accrocher tout ça pour.
Nous, l'erreur qu'on avait fait, c'est que on était obligé de sortir toute l'électronique à chaque fois. Alors que si on avait prévu juste un petit trou pour mettre un câble USB, on aurait pu faire ah, la loi de commande, elle est pas bonne. Là, c'est bon. Alors qu'à chaque fois, on devait sortir l'électronique, se brancher, rechanger le truc, réenlever, refermer, machin, réinstaller en haut parce que t'enlèves la coiffe.
Ouais.
Et on s'est dit, putain, ça n'avait juste un trou pour le câble USB. Ce serait tellement plus.
T'as du VOST que tu peux le connecter en Bluetooth. Ça, c'était.
Tu peux le programmer en Bluetooth?
Ouais, le contrôler.
Ah, le contrôler.
Pas le programmer. On pourrait peut-être envoyer aussi Non, pour l'envoyer programme, fallait forcément un câble.
Ok, bah, je pense qu'on a fait le tour. Ouais, j'avais tout demandé. Ouais.
Ok.
Du coup, bon courage pour cette année.
Merci.
Ne faites pas un tank.